So guys, welcome to our channel once again. In today's video, we have here these 10 questions to answer on the topic wave particle paradox. So in short, it's set to the end of this video. Let's go ahead and start with the first question here. It says, the electron of mass 9.1 times 10 to the power of negative 31 kg is traveling at a speed of 2.0 times 10 to the power of 6 meter per second. Calculate the associated wavelength of the electron. Take Planck's constant to be 6.6 times 10 to the power of negative 34 joule seconds. Alright, so guys, here from de Broglie's equation, we are going to have that the wavelength lambda here will be the Planck's constant h over the linear momentum p. So if we take the Planck's constant h and divide by the linear momentum, so let's note that the linear momentum is mass times velocity here, and the mass is given, the velocity is also given. So let's go ahead and plug in the values here. We'll have wavelength lambda is equal to h, which is 6.6 times 10 to the power of negative 34, over the mass, which is 9.1 times 10 to the power of negative 31, times the velocity, which is the speed here, 2.0 times 10 to the power of 6. So guys, when we go ahead and calculate this, we'll have 3.63 times 10 to the power of negative 10 meters, and that's option D here. So let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 2. It says, there is always an uncertainty involved in any attempt to measure the position and momentum of an electron simultaneously. This statement is known as the A. wave particle paradox, B. Frank Hertz's experimental law, C. de Broglie's law, D. Heisenberg uncertainty principle. So guys, the answer to this question is option D here. That's the Heisenberg uncertainty principle. So let's go ahead and consider the next question, guys. So the next question we have here, question number 3, says, let delta x be the uncertainty in the measurement of position and delta b the uncertainty in the measurement of momentum. Then the uncertainty principle relation is given as A. delta x delta p is less than or equal to h. B. delta x times delta p is equal to h. C. delta x times delta p is greater than h. D. delta x times delta p is greater than or equal to h. So guys, the answer to this question is option D here. So that's it for this question. Let's go ahead and consider the next question, guys. So guys, the next question we have here is question number 4. It says, an electron moves with a speed of 2.0 times 10 to the power of 6 meter per second in a straight line. Calculate the wavelength of the electron wave. Alright, so guys, we are going to use the equation wavelength, which is lambda is equal to hc over half mv squared. So guys, in this case, h is the Planck's constant given as 6.6 times 10 to the power of negative 34. Then c is actually the speed of light. Then also we have the mass given here, the mass of the electron, which is 9.1 times 10 to the power of negative 31. And then finally we also have the velocity, which is the speed of this electron. That's 2.0 times 10 to the power of 6. So guys, if we impute all these, we are going to have that lambda is equal to the Planck's constant 6.6 times 10 to the power of negative 34 times the speed of light, that's 3 times 10 to the power of 8, then over the half mv squared, so that's the mass times the velocity squared all over 2. So mass here is actually 9.1 times 10 to the power of negative 31 times the square of the velocity. Actually, the velocity here is this speed, 2.0 times 10 to the power of 6. So we'll square it here and then we'll divide all this by 2. Actually, you can bring up the 2 to the above and this becomes 2 times the Planck's constant 6.6 times 10 to the power of negative 34, then times the speed of light 3 times 10 to the power of 8, then all over the mass 9.1 times 10 to the power of negative 31 times the square of the velocity, that's 2.0 times 10 to the power of 6 all squared. So guys, let's go ahead and calculate this and see what we have here. So guys, we'll have 4.24 times 10 to the power of negative 8 meters, and that's option C here. So guys, let's go ahead and consider the next question. So guys, the next question we have here is question number 5. It says, which of the following scientists suggested that moving particles exhibit wave properties? We have A. Isaac Newton, B. Louis de Broglie, C. J.J. Thomson, and D. Ernest Rutherford. So guys, the answer to this question is option B here, Louis de Broglie. So that's it for this question. Let's go ahead and consider the next question, guys. So the next question we have here is question number 6. It says, which of the following pairs of concepts constitutes complementary variables as expressed by the Heisenberg uncertainty principle? We have A. Momentum and time, B. Energy and acceleration, C. Velocity and momentum, D. Position and momentum. So guys, the answer to this question is option D here, position and momentum. So that's it for this question. Let's go ahead and consider the next question, guys. So the next question here, question number 7, says, it is always not possible to determine exactly and simultaneously the position and momentum of a particle. This statement is known as the A. Compton effect, B. Heisenberg uncertainty principle, C. Frank Hertz's experimental law, D. de Broglie law. So guys, the answer to this question is option B, Heisenberg uncertainty principle. And that's it for this question. Let's go ahead and consider the next question, guys. So here we have question number 8. It says, which of the following phenomena best supports the wave nature of matter? We have A. Photoelectric effect, B. Electron momentum, C. Electron diffraction, and D. Blackbody radiation. So guys, the answer to this question here is option C, and that's electron diffraction. So we'll go ahead and consider the next question here, guys. So guys, the next question we have here is question number 9 here. It says, if the kinetic energy of an electron is 100 electron volts, what is the wavelength of the de Broglie wave associated with it? Alright, so guys, the de Broglie wave here can be given as lambda is equal to the Planck's constant over momentum. So guys, here we have the Planck's constant given, but momentum is mass times velocity, and we don't have the velocity here, but we can get the velocity by having that kinetic energy is equal to half mv squared. So in that case, we can make the v squared the subject of this equation, where v squared becomes 2ke over m. So that's the mass of the electron here. So 2 times the ke here, that's the kinetic energy, is alright. So guys, the kinetic energy is actually 100 electron volts, and actually an electron is 1.6 times 10 to the power of negative 19. So if we I have to convert these 100 electron volts to energy. We're going to multiply it by 1.6 times 10 to the power of negative 19. So that will give us 1.6 times 10 to the power of negative 17 here. So in that case, we'll have that v squared is equal to 1.6 times 10 to the power of negative 17 times 2, then all over 9.1 times 10 to the power of negative 31. Then v alone is going to be actually the square root of this. So let's go ahead and calculate that. So guys, for this, the velocity here now becomes 5.933 times 10 to the power of 6. So that's it here. So if the velocity now becomes 5.933 times 10 to the power of 6, then we can now input this in the overall equation where lambda is equal to h over mv. So h is a Planck's constant, which is 6.6 times 10 to the power of negative 34. So this will be divided by the mass, which is 9.1 times 10 to the power of negative 31 times the velocity, which is 5.933 times 10 to the power of 6. So guys, when we go ahead and calculate this, we'll have 1.22 times 10 to the power of negative 10 meters. And that's option A here. So that's it for this question. Let's go ahead and consider the next and last question, guys. So guys, the last question we have here, question number 10, says, which of the following phenomena supports the theory that waves have a particle nature? So we have A, photoelectric effects, B, electron diffraction, C, diffraction of light, D, X-ray interference. So guys, the answer to this question is option A, photoelectric effects. So the photoelectric effects actually supports the phenomena of the theory that waves have particle nature. So that's it for this question. So this is where we'll end this video for today, guys. If you enjoyed this lesson, please give it a thumbs up. Don't forget to subscribe to this channel if you're not a subscriber. Also, if you have any specific question regarding this video, you can drop your question on the comment section below and we'll ensure to give you a response. So finally, guys, we want to encourage you to join our YouTube channel community. So you can join this channel community by hitting the join button below, and we'll see you right there. Thank you once again for watching this video, and see you on the next one.